mosses, roots and stems which lie in it, and so soft that everything would sink into it if it were not for the matted roots of the mosses, ferns, and other plants which bind it together. You may dig down for 10 or 15 feet and find nothing but peat made of the remains of plants which have lived and died there in succession for ages and ages, while the black trunks of the fallen trees lie here and there, gradually being covered up by the dead plants. The whole place is so still, gloomy, and desolate that it goes by the name of the Great Dismal Swamp, and you see we have here what might well be the beginning of a bed of coal, for we know that peat, when dried, becomes firm and makes an excellent fire, and that if it were pressed till it was hard and solid, it would not be unlike coal. If, then, we can explain how this peaty bed has been kept pure from earth, we shall be able to understand how a coal bed may have been formed, even though the plants and trees which grow in this swamp are different from those which grew in the coal forests. The explanation is not difficult. Streams flow constantly, or rather ooze, into the Great Dismal Swamp from the land that lies to the west, but instead of bringing mud in with them as rivers bring to the sea, they bring only clear pure water, because as they filter for miles through the dense jungle of reeds, ferns, and shrubs which grow round the marsh, all the earth is sifted out and left behind. In this way the spongy mass of dead plants remains free from earthy grains, while the water and the shade of the thick forest of trees prevent the leaves, stems, etc., from being decomposed by the air and sun. And so, year after year, as the plants die, they leave their remains for other plants to take root in, and the peaty mass grows thicker and thicker, while tall cedar trees and evergreens live and die in these vast swampy forests, and being in loose ground are easily blown down by the wind, and leave their trunks to be covered up by the growing moss and weeds. Now we know that there were plenty of ferns and of large calamites growing thickly together in the coal forests, for we find their remains everywhere in the clay, so we can easily picture to ourselves how the dense jungle formed by these plants would fringe the coal swamp, as the present plants do the Great Dismal Swamp, and would keep out all earthy matter, so that year after year the plants would die and form a thick bed of peat, afterwards to become coal. The next thing we have to account for is the bed of shale or hardened clay covering over the coal. Now we know that from time to time land has gone slowly up and down on our globe, so as in some places to carry the dry ground under the sea, and in others to raise the seabed above the water. Let us suppose, then, that the Great Dismal Swamp was gradually to sink down, so that the sea washed over it and killed the reeds and shrubs. Then the streams from the west would not be sifted any longer, but would bring down mud and leave it, as in the delta of the Nile or Mississippi, to make a layer over the dead plants. You will easily understand that this mud would have many pieces of dead trees and plants in it, which were stifled and died as it covered them over, and thus the remains would be preserved, like those which we find now in the roof of the coal galleries. But still there are the thick sandstones in the coal mine to be explained. How did they come there? To explain them, we must suppose that the ground went on sinking till the sea covered the whole place where once the swamp had been, and then sea sand would be thrown down over the clay and gradually pressed down by the weight of new sand above, till it formed solid sandstone, and our coal bed became buried deeper and deeper in the earth. At last, after long ages, when the thick mass of sandstones above the bed B, figure 46, had been laid down, the sinking must have stopped, and the land have risen a little, so that the sea was driven back, and then the rivers would bring down earth again and make another clay bed. Then a new forest would spring up. The ferns, calamites, lepidodendrons, and sigillarias would gradually form another jungle, and many hundreds of feet above the buried coal bed B, a second bed of peat and vegetable matter would begin to accumulate to form the coal bed A. Such is the history of how the coal which we now dig out of the depths of the earth once grew as beautiful plants on the surface. We cannot tell exactly all the ground over which these forests grew in England, because some of the coal they made has been carried away since by rivers, and cut down by the waves of the sea, but we can say that wherever there is coal now, there they must have been then. Try and picture to yourselves that on the east coast of Northumberland and Durham, where all is now black with coal dust and grimy with the smoke of furnaces, and where the noise of hammers and steam engines and of carts and trucks hurrying to and fro makes the country re-echo with the sound of labour, there, ages ago, in the silent swamp shaded with monster trees, one thin layer of plants after another was formed, year after year, to become the coal we now value so much. In Lancashire, busy Lancashire, the same thing was happening, and even in the middle of Yorkshire and Derbyshire the sea must have come up and washed a silent shore where a vast forest spread out over at least 700 or 800 square miles. In Staffordshire, too, which is now almost the middle of England, another small coal field tells the same story, while in South Wales the deep coal mines and number of coal seams remind us how for centuries and centuries forests must have flourished and have disappeared over and over again under the sand of the sea. But what is it that has changed these beds of dead plants into hard, stony coal? In the first place, you must remember they have been pressed down under an enormous weight of rocks above them. We can learn something about this even from our common lead pencils. At one time the graphite, or pure carbon, of which the black lead, as we wrongly call it, of our pencils is made, was dug solid out of the earth, but so much has now been used that they are obliged to collect the graphite dust and press it under a heavy weight, and this makes such solid pieces that they can cut them into leads for ordinary cedar pencils. Now the pressure which we can exert by machinery is absolutely nothing compared to the weight of all those hundreds of feet of solid rock which lie over the coal beds, and which has pressed them down for thousands and perhaps millions of years. And besides this, we know that parts of the inside of the earth are very hot, and many of the rocks in which coal is found are altered by heat. So we can picture to ourselves that the coal was not only squeezed into a solid mass, but often much of the oil and gas which were in the leaves of the plants was driven out by heat, and the whole baked, as it were, into one substance. The difference between coal which flames and coal which burns only with a red heat is chiefly that one has been baked and crushed more than the other. Coal which flames has still got in it the tar and the gas and the oils which the plant stored up in its leaves, and these, when they escape again, give back the sunbeams in a bright flame. The hard stone coal, on the contrary, has lost a great part of these oils, and only carbon remains, which seizes hold of the oxygen of the air and burns without flame. Coke is pure carbon, which we make artificially by driving out the oils and gases from coal, and the gas we burn is part of what is driven